Section 2.4. We start with derivatives of trig functions. We have two limits, and I'm going to take the limit right there. And I'm going to make sure that I am in radian mode. And that is radians. And I'm going to take the limit as x approaches 0 of sine of theta over theta. So I'm going to take 0.1, 0.01, and see if this is lining up. And how does this work? Well, let's see. If I take, let's say, 0.1 stored in my answer, now I take my sine of the answer divided by answer. .99833. And if I get a bit closer, 0.01, 0.999833. And if I get a bit closer, 1, 2, 3, 4, 5, 6 nines. So I am confident that this is pretty much is one from those three. I don't need that. I could do that. But how about the negative? Because I need to check the positive and the negative. Well, does the negative make a difference? Well, 0.1, oops, negative 0.1, and if I evaluate that, that turns out to be the same. 0.998334, whatever. And if I go by negative 0.01, 4 nines, well, it's turned out to be the same thing. So I'll try one more just so that, oops, negative 0.00. Now most calculators, you put the number and you hit the negative, it makes it a negative, but not this calculator. That's okay. Just make sure that you're acquainted with yours, and there it is, the same deal. So, and similarly, I could show that that limit equal 1. Now, the limit of sine and cosine are the only two values that require me to use some trig identities. Besides that, I just use, what I mean by identities, I mean the sum and difference formulas, which, you know, we don't use much. Find the derivative of y equal the sine of x by using the definition. Well, the derivative of sine of x is, if you remember, f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the sine of x plus h minus the sine of x all over h. Of course, you let, oops, I forgot the most important aspect of the problem. Otherwise, this is nothing more than average rate of change. Now it's a derivative. If I plug 0 in, I'll get the sine of x minus sine of x. That's 0 over 0. So this is the limit as h approaches 0. And I'll use the sum, if you remember, that's sine of x cosine of h plus sine of h cosine of x minus sine of x all over h. Now, I am going to take those two, and I'm going to break this into two fractions. I'm going to take this into the sine of x cosine of h minus sine of x plus the limit as h approaches 0 of the sine of h over h cosine of x. That's going to be the limit as h approaches 0. I'm going to factor a sine out of this. I'll be left with cosine of h minus 1 over h plus the limit as h approaches 0. Well, this is independent of h. So that's a constant as far as h is concerned. You know what? Let me write it in 2 steps. H approaches 0, sine of h over h times cosine of x. So this is independent of h. I factor that out. The limit as h approaches 0 of cosine of h minus 1 over h, plus this is independent of h. That's a constant as far as h is concerned. I factor that out. And you'll notice this right here, cosine of h minus 1 over h, is really right there. That's a 0. So that is the sine of x times 0 plus the cosine of x. And you notice that this is the sine of h over h. It's right there. That's a 1. And I'll get 0 plus the cosine of x, which is the cosine of x. So, bottom line, if y equals sine of x, the derivative of that is the cosine of x. Now, I would not ask you to do anything like sine or cosine using the definition. I will ask you to find the derivative using the definition, like 2.1, 2.2, right? But nothing like this sine or cosine. The traditional functions. So, traditional functions are rational, radical, polynomial, and what else did we use? I think those were it. Okay, now a derivative of sine is cosine, derivative of cosine is negative the sine, derivative of secant is secant tangent, derivative of cosecant is negative cosecant cotangent, derivative of tangent is secant squared, and derivative of cotangent negative cosecant squared. I'm going to derive one for you really quick. So if I say show, I do not say use the definition. Show the derivative of cotan of x equal negative cosecant squared. Well, you say, okay, derivative of cotan of x is actually the derivative. Cotan is cosine of x over sine of x. Doesn't this require the quotient rule? Derivative of the top, derivative of cosine is negative the sine of x times the denominator minus the top times derivative of the denominator all over the denominator squared. That's going to equal negative sine squared of x minus cosine squared of x over sine squared of x. If you factor a negative out, you'll get sine squared of x plus cosine squared of x over sine squared of x. And this is the most famous identity, the Pythagorean identity. Sine squared of an angle plus cosine squared of an angle is a 1. And what do we know? We know that 1 over sine squared is the cosecant squared of x. So the derivative of cotangent is negative cosecant squared of x. The way I memorized this back in the days, I memorized the left 3. I memorized that derivative of sine is cosine. Derivative of secant is secant tangent. Derivative of tangent is secant squared. So these are all the s's, the sine, secant, and tangent. When I went to the cofunction, derivative of cosine is the sine, but with a negative. Derivative of cosecant, just like derivative of secant, I have memorized secant tangent. Derivative of cosecant is cosecant cotangent with a negative. Derivative of tan is secant squared, so derivative of cotan is the cosecant squared with a negative. So every time I take a derivative of the cofunction, the cosine, the cosecant, the cotan, I should remember that I'm going to pick a negative. So, assuming you have that next to you as you do the homework until you get the hang of this, now it's nothing more than practice. That's about 3/4 of the section. So, the following derivative, find the derivative of the following. Well, what's the derivative of this? The product rule. Derivative of the first times the second plus the first times derivative of sine is cosine. What's the derivative of tangent? Is secant squared of x. Done deal. Same deal here, the product rule. If I want to find y prime, that's 2x times cosecant of x plus x squared. Derivative of cosecant, again, derivative of secant, secant tangent. cosecant is cosecant of x cotan of x with a negative, and derivative of secant is secant of x tan of x. So you could clean it up again. You could leave it as is. It really doesn't matter. 2x cosecant of x minus x squared cosecant of x cotan of x plus secant of x tan of x. Lengthy problems, but they're not hard. How about here? I have the product of two functions. You are welcome to convert tangent to sine over cosine and do the quotient, whatever you like. But to practice this section, I'm gonna work it out head on. So I'm gonna treat those like two different functions. Y prime, derivative of tangent is secant squared of x times the second plus the first, derivative of sine is the cosine. Now, of course, you could clean that up. You know, this is 1 over cosine. This is sine over cosine. You could clean up a bit. For the homework, you want to do that. For a test, this is all I want. For this chapter, find me the derivative and that's it. For the next chapter, we're going to figure out the maximum, minimum, or increasing, decreasing. That's when you're going to do all of these algebraic manipulations. For now, just show me that you know the calculus. That's all I want. And how about here? Well, the quotient rule. Y prime would be derivative of the top is secant of x tan of x times the bottom minus the top derivative of the denominator is simply a 1 over the bottom squared. And again, on a test, you don't need to clean anything. If I say find the derivative, just find the derivative. That's good enough. The algebra is coming along. Here, the quotient rule again. Y prime or f prime. Derivative of the top is the cosine of x into 1 plus cosine of x minus derivative of the top times derivative of the denominator is negative sine of x all over the bottom squared. Again, on a test, that's good enough, but those clean up really nice. That's cosine of x plus cosine squared of x plus sine squared of x. And you'll notice that this is, I'm not trying to save space, I just want them to line up properly, to look nice, nothing more really. We have plenty of space, you know. That would equal, that's a 1. This cancels with one of those. And that would be the answer. On a test, this is all I want. You don't have to clean anything on an exam. Just find me the calculus, leave the algebra alone, we'll deal with that later. And if I want to take a derivative of part f, f prime would be the product rule, but that's 3 functions, that's okay. We could treat those as one function. So take a derivative of this, the product rule, 2x times cosecant of x minus x squared derivative of cosecant is cosecant of x cotan of x times the second plus the first times derivative of cotangent is negative cosecant squared of x. Again, this is all I want. You could clean it up on the homework. Check what you have. Nope, I went way too far. Alright. Continuing on. Seems I could adjust. Find an equation of the tangent. Well, hey, guess what? Y minus y1 equal m into x minus x1. Almost done. What's missing? Slope of the tangent. That's a derivative. That is just thinking out loud. Give me 1 sec. I just realized I did that problem a bit. I didn't realize we didn't do that chain rule yet. Okay, so there's one way of doing this. The long way, but after the next section we'll do this a lot faster. And that is to say that y equal twice the sine of x cosine of x. For now, that's sufficient. If I take a derivative, twice the product rule, derivative of the first times the second, plus the first times derivative of the second. Derivative of cosine is negative the sine. Derivative of tangent is secant squared of x. So y prime is twice cosine squared minus sine squared is the cosine of 2x. Again, in the next section we'll figure that out. At pi over 4, this is 2 times pi over 4 is pi over 2, that's a 0. Secant of pi over 4 is radical 2 squared, that's a 2, so that turns out to be a 2. Done. Some trig. And if you ever were in doubt, there's 45 degrees, 1 radical 2. Secant is the hypotenuse over the adjacent. Radical 2 over 1. When you square it, you get a 2. Here, the same deal. Well, y minus y1 equal m into x minus x1. So, derivative, slope of the tangent, that's product rule. At x equal pi, that's a negative 1 minus pi times 0. So that's negative 1. There's the equation of the line, and done deal. I'll finish this in the next section.